So hi everybody, it's Monday, May 24th, 2021. Today we have Alan Altmark back with us to do part 2 of the ZVM virtual switch session. So I'll turn it over to Alan.
Thank you, Bill. Good morning, good afternoon, good evening to everybody. Thank you for joining. This presentation does continue basically where the one we did a couple of weeks ago left off. In fact, typically when I'm presenting these, I actually do them as a pair, but for logistical reasons, we had to split them up. But we'll have a little bit of review here. One of the things that we started talking about in the previous presentation was something called link aggregation. And when we think about how a switch works, or at least when we think about how our virtual switches work, it was always traditional to provide 1, 2, or 3 OSAs for it to use. And those were used in case if one failed, it went over to the next one. If that one failed, it went to the next one. If that one failed, just kind of round robin through those. And if they all had died, it would just sit there and wait for something to come alive. And then it would pick up and do that. And that's one way to run. That's called failover mode. And if something goes wrong, there is really no protocol to deal with the outage. And it's kind of a shock to both to the DVM side and to the switch, because if we move from one OSA to another, the switch actually has to learn new things, and ZVM has to take time to teach it. So it can be a little bit of a slow process depending on how many guests are active. And generically, that is called channel bonding, and it's called and it's a failover channel bond. A more sophisticated version of channel bonding is called link aggregation. And this form of channel bonding is an IEEE standard. In fact, it's no longer a lowercase AD. I think it's now uppercase AD. It's official. So in link aggregation, what we do is we actually run multiple active ports at the same time. Now, that gives us a couple of interesting things. And when we have to run them, when we're running them together, then that means there's something coordinating traffic going back and forth. It's not random. You know, there is a form of channel bonding where basically think of a dealer with cards and you're dealing out the packets and you can just go one to the next. And that's not good. That creates problems with reassembly at the other end. You really do want packets that are following each other to literally follow each other in the network. That actually allows both ends to be most efficient about sending and receiving. But in this form, what happens is that we're able to associate each of those virtual NICs with a physical OSA port. In this picture, what I'm showing is that there are 4 active OSA ports in this link aggregation group. Now, this grouping goes by various names. In ZVM, we call it a port group. On Cisco devices, you hear it called a port channel. Okay, so it's a channel that's made up of 2 or more ports, and they act as a single port. Basically, once you get past you see a gray box in the middle called the aggregator. And once you get past that, it's really transparent that there are multiple ports involved. Nobody really knows that that's how it happened. But this protocol that's being used to communicate is called LACP, Link Aggregation Control Protocol. And because you have multiple ports active, you're actually able to communicate status about errors on a port. Let's say in this case, port 1 has some sort of failure. I can use ports 2, 3, or 4 to actually report that I'm removing port 1 out of the group, okay? So I can do a lot of status notification over the other ports. So it makes for a very fast and very seamless way to add and delete ports from the port group. And we'll talk a little bit more about that. But it's this LACP protocol that makes this work. Now, when we do this, all of a sudden these OSAs are stateful. Normally, OSA, we think about, well, you know, I don't really care. It's just sending packets. No worries, and we share them. All right, now when I'm running LACP, when I'm using link aggregation, I can't do that quite the same way. So if I'm running in this mode, I cannot share those OSA ports that I'm using with anything other than another link aggregation VSwitch. Okay, we'll actually talk about that, how we share these port groups is really what you're sharing. But if these OSAs, when I look at them, I go, I can't share it with ZOS, I can't share it with a traditional vSwitch, I can't share it with BSC, Linux. I can't do any of that at the LPAR level. In fact, there are hardware switches in the firmware that will prevent the sharing. If you don't follow the exact precise sequence, the OSA will not allow you to share it. And only ZVM knows the right sequence to cause that sharing to occur. So what you get in this case are what really happens under the covers. We can have up to 8 of these, right? Up to 8 OSAs in the port group. Now, I do get this improved manageability, but I also get faster failover, okay, because there's communication going on. I also get load balancing. Okay, now either side can choose to load balance, and every so often ZVM will actually balance. What he's balancing is the number of virtual NICs per physical OSA. Now, that's how it all began. Now, over the years, the load balancing has gotten a little more sophisticated, Switches, the physical switches, have extremely sophisticated port balancing, and they're the ones that are actually more likely to introduce a port balance. They might notice from a traffic rate point of view, more sophisticated traffic monitoring, and they can actually cause ZVM to rebalance. They can say, here, we need to move these things around and change the assignments. So there's a virtual NIC, it's associated with an OSA, and it stays there until it needs to move because of load balancing or because of a failure of that OSA. Now, in theory, the protocol also includes, but ZVM does not implement, the ability to send sort of these little chasers through those links so that you can actually tell, oh, I transmitted 8 packets and they all arrived safely. Now, I don't need to remember about them. I don't need to worry about them anymore. But if there were a failure while I was transmitting them, I could just retransmit those 8 packets all at once on another OSA. And what that means is that TCP timers don't trip up. I'll get some extra packets at the far end, duplicates, but that's okay. I'm looking forward to the time when ZVM does implement that. It does not do that today. That can actually help TCP connections be more reliable and actually not have these waits while they time out. Right? So occasionally we rebalance, change those assignments, and that's what link aggregation does for you. Now, I mentioned it's up to 8. You do get increased bandwidth because you can think about I'm running a 10 gig OSA. If I'm doing one at a time, what's my bandwidth? 10 gig. If I'm running 2 of them, what's my bandwidth? 20 gig. Okay, I can't do that with one OSA. I can only do that with multiples at a time. I haven't run into cases where OSA bandwidth is a problem, but I hear that in a few, none of my clients have had an issue there. But I have heard of people who do start to reach the limits of an OSA in terms of bandwidth, and so this has been good for them. It is only supported for Ethernet mode vSwitches. So most of our advanced technology in the vSwitch is in the Ethernet mode, okay? That brings with it the need to manage MAC addresses, but you get technology like this in return. I should point out, as it says here, that a single virtual NIC is assigned to a single port, single OSA port. So a single virtual NIC is still limited to the bandwidth of a single OSA, because again, we don't want to be dealing the packets out on different OSAs, so they'll all go out a single OSA. I can move it if I need to a different OSA, but it'll still be one OSA at a time. Now, what I'm showing here is the complex way of setting up an OSA port group. You simply say set port group, give it a name, and tell it what OSAs, up to 8 OSA ports, that you want in there. This one's got 2 OSA ports. Then you create a vSwitch and you reference the name of the port group. You're now done, okay? So it takes the OSA membership away from the vSwitch, okay? The vSwitch no longer has device numbers in it. It just has the name of a port group, right? And if I want to add or remove OSAs from the port group, I do so with the set port command, okay? Now, those OSAs, as I mentioned, that are tied up in a port group cannot be shared unless you're using shared port groups, and that only occurs with the ZVM vSwitch. Can't have other uses of the OSA sharing that. We'll talk more about that. So I consider using link aggregation to be a best practice for the vSwitch. Now, one of the things in my picture, which I should have pointed out, if we look at the bottom, you'll see that I actually have 2 physical switches. So this technology works. It comes in a variety of names, ether channels, port channels, but these things are virtual chassis, VSS, its vendor specific name, but what it means is that in that case, I've got two physical switches that are themselves trunked together, and that port channel is spanned across multiple switches. They act as though they are a single switch. And it's this way because switches get rebooted. It happens. They're part of normal maintenance, error recovery, variety of reasons. And if a switch goes down, you would like to be able to continue using that. Well, in fact, if the switch B goes down, switch A knows, and it will notify us to remove port 3 and 4 from the port group. Okay? So we'll be able to handle that. So in that case, in this kind of configuration, you're covered, well covered from cable failures, connector failures, port failures, switch failures. You're doing pretty well. Essentially, you've got the best high availability for an OSA connection, for a network connection that you can have. Now, of course, the virtual machines know nothing about this. They have no idea that this is happening, and that's exactly how we wish it to occur. So you have situations where people who come from a background where they look at, particularly when they come from a ZOS networking background, where the idea there is to run multipath routing and run OMP route, and to have multiple networks and have failover networks and have a VEPA. When you use this kind of technology, you don't need that stuff. And so we don't implement it, we don't do it, and you don't need it for the Linux guests. And you put, and I recommend that you put VMTCP/IP on the vSwitch. In the early years, VMTCP/IP, we kept its own OSA connections because vSwitch was still new at the time, but now vSwitch is well-traveled feature of VM, and I am perfectly comfortable putting VMTCP up there. And when you do that, then you do not need to be running MP route for VMTCP/IP, which is problematic having that there. So I recommend putting all of the guests on here. Because it's an Ethernet mode vSwitch, one of the things that you cannot put on here is ZOS. Okay, so ZOS cannot participate as a guest, cannot participate in a link aggregation vSwitch because it cannot use an Ethernet mode vSwitch. All right, now that sharing, like one case where you can do it. So we call this, I heard this called shared lag. But basically, when the Z13s were introduced, new firmware was added to let us do a little bit more control over that sharing. And you think about this, a 4-member SSI cluster will use at least 8 ports. Okay, it'll fill that up. Now, let's say you had 4 clusters. Well, now you're using 32 ports. Not only is that a very significant capital investment in all of the network activity, there's a limit of 48 OSA chips in the machine. So you can fairly quickly, when you're not sharing OSAs, you can very quickly run out of capacity. If you've got a large machine and you've got multiple test LPARs, you've got a couple production LPARs, you're doing a lot of work there, it's not too hard. We have had clients who are approaching that limit, which caused us to create this shared port group configuration. So on current machines, you now have the ability to share the port group. Okay? You won't share, don't think about it as sharing the individual OSAs for other purposes, but you can have a port group that spans multiple LPARs, multiple VM LPARs. So if I've got 2 test LPARs, they can share the test, if you will, the test port group. Production LPARs can share the production port group. Okay? So that is one way to reduce the cost. Now, those vSwitches that you're sharing with can be in the same LPAR or a different LPAR. So it's interesting, we think about sharing as being cross LPAR, but in fact, I can have multiple vSwitches sharing the port group. And because I have different attributes to my vSwitch that I care about, I want to do things at the vSwitch level. So I'll share the port group. Now, in order to do the sharing, a couple of things come into play. First of all, remember how those 2 physical switches were trunked together? Well, now we have to sort of think of this as trunking together the virtual switches. So a new kind of link has been created called an inter-vswitch link. Sort of think of it in Cisco terms, they call these ISLs. We call ours an IVL. And what it is there for is to provide, primarily to provide management of the vSwitches. Data communication can occur. In other words, a system can end up sending the guest across the IVL to the other system to actually reach the OSA. There are some very strange OSA failures where the OSA looks like it's there, but it isn't. There are occasional firmware problems that crop up. And that can cause that, but I just don't see it in the wild. I hear about it from time to time, but none of my clients have ever actually run into the issue. So you have this link to connect the VM systems together. And then you change the attribute of the vSwitch. So the vSwitch actually becomes a global vSwitch. I'll show you how that's done. And really so if you have a global vSwitch, allows the port groups to span vSwitches, and then you have the IVL to connect them together. Now, and we think about these IVLs, we can think about dividing up the world into IVL domains. Okay, now an IVL domain provides all the control and error recovery for all global vSwitches that are part of the domain. When I define a vSwitch, I specify what domain it is a part of. Okay, so what that means is if you got two LPARs that are sharing the same port group, then they must be members of the same domain. Okay, I can split things up if I want to, but not if we're sharing. But I can certainly say, oh, my test domains, my test port groups are in one domain, and my production port groups are in another domain. Okay, just helps create some management isolation, okay, and potentially some traffic isolation. Okay, and we create these domains through a special vSwitch called an IVL VSwitch. Now, it gets kind of strange, and I'm going to talk about this a bit because the process, when you're doing global vSwitches, they don't become active immediately. So you get, in fact, the vSwitches don't get defined. Their definition is deferred in the system until the domain is set up, till CP is happy with the domain configuration. When he's happy with that, then he allows the defined vSwitch. It's basically being held pending, and it waits until the IVL is up. That creates some very interesting issues for system initialization, system startup. Talk about. So to create the IVL vSwitch, it's a defined vSwitch. You say type IVL and assign the domain. If you want to use VLANs, if you want to share, but you want to share because you can share OSAs for this, and you can define them on different VLANs. You have up to 8. There's a firmware restriction, and you can put at most 16 LPARs in an IVL domain. Okay, and a VM LPAR can only be in one. Okay, so if that test production thing talked about means that, well, I can't have test vSwitches and production vSwitches in the same LPAR and hope to have them in different domains. It won't work. Okay, but somebody told me, oh, I've got test and development and production in the same LPAR. I'm like, we got to have another talk, okay? Because you probably shouldn't be doing that in any case. Now, these can use conventional. You don't have to. You can use an exclusive port group, but you can also just use conventional RDEV. So the IVL domain, because it's not typically handling a lot of traffic, doesn't need a lot of capability here. And no, you cannot use the same OSAs that you're trying to use in a global port group as the OSAs that the IVL vSwitch is going to use. So you got a few options with the set vSwitch command for IVL. You can change the VLAN ID associated with it. You can terminate it and recreate the IVL port connections. The one I like is set vSwitch IVL port ping. And it will actually test that it's able to talk to the other LPARs. Okay, or I should say, if I was actually sharing on the same system, it would be pinging itself. Because the thing about an IVL is that it's not an IP thing. Okay, it doesn't use TCP IP. It happens to be using multicast groups at the layer 2 level. And so we basically think of that as an Ethernet level ping without the IP part. You can also adjust how often he confirms connectivity with the other ones, because if he loses connectivity, then all of a sudden the vSwitch is going to go down. Okay, basically the OSAs are going to stop because he doesn't know what's happening in the other LPARs. He can't properly manage it. Now the set port group, I'm going to do exactly what I've been doing, but I'm going to add the shared attribute. Okay, because it is a shared port group, and everything after that is the same. Now, what's kind of cool, if I change the port group definition on one system, it will automatically propagate to the others. I don't need, if I add or delete an OSA from the port group, I can do it from any of the systems that have that same shared port group defined on them. It will automatically propagate. Don't worry about the device numbers. It's a case of the system will find, because it doesn't care what the device number is. It tells the others, and here's what chip and what port you want. And the remote systems will all find an available device on that chiplet, okay? And then they will select that port. So they'll do it dynamically. You don't have to worry about it. When you define the vSwitch, what you do is you're adding the global attribute, okay? Now, it means that the vSwitch is named the same in all the LPARs. And what will happen is every time when this gets done, you actually get an instance of the shared port group is created when it's configured to the virtual switch. So each of the systems will have an instance of the port group. And just to give a picture here of what's going on, here I define a port group, P channel 32, say it's shared. I add the OSAs to it just like I was doing without the shared part. When I define the vSwitch, I add the global attribute. Ta-da, I'm done. Okay, so what happens is that the vSwitch names change slightly. Whereas before you had vSwitch names, you'd see system would be the owner. It changes. The LPAR becomes the owner. And that's sort of a visual clue that you're working with a global vSwitch. Now, in this picture is also showing that the shared port group, that P channel, you can see that it's, if I change it on one side, it will change it on the other. Now let's talk more about the hard part of this, the thing where you do have to take action. Okay, it's easy enough to add attributes, but when you do, you have to change system startup. Rule number 1, as we know, guests cannot connect to a vSwitch until it is defined. And a global vSwitch can't be defined until the port group has been formed, and the port group does not form until the IVL is up and has discovered the other members of the IVL domain. That means just putting stuff in system config isn't going to work. If you go ahead and start the guests, the NIC defs will not be able to connect to the vSwitch. It's not defined yet. Okay? What you need to do is make sure that the guests do not start until messages are issued, which indicates that if you've got some automation software, the automation software, you basically get the guest startup, get any guest that's dependent on the vSwitch, you get its startup out of Autolog 1, Autolog 2. You get that out of there, and you make it the responsibility of your automation software to do that. When it sees the message that says, oh, okay, IVL is up, you get the messages that say the vSwitch is defined. At that point, you can bring up the guest. Or you can actually put polling logic in Autolog 1 or 2, which is watching, that actually sits there and spins, check, delay, check, delay, check, delay, and looks for the vSwitch to become up. When the vSwitch is up, then it can proceed to bring up the guests. Okay, I have no personal preference as to which one you do, but you got to do one of the two. Nothing like people doing this and watching their entire initialization fail. Okay, just because they added the attributes in system config. Okay, any questions on the global vSwitch?
Just a quick question. Can all of the global vSwitch definitions go in the system config?
Yes, you would put them in there just as you have today. You, of course, don't have to, but I always recommend the definitions go there. But it's just that they'll be defined, but there's a delay well after Autolog 1 is started before the vSwitch actually is instantiated. The define command is being issued in system config, and then eventually the define completes. You have the same issue if you try to put the define in Autolog 1. The define will go in, it will be deferred until the IVL comes up, and then it will activate. So regardless of where you define the vSwitch, if you're going to use global vSwitches, you've got to add logic in your startup procedures that waits for the global vSwitch to initialize. Okay. Now, in the case where I had VM TCP IP on a vSwitch, well, if it was a global vSwitch, I need to wait. Okay, I can't bring TCP IP up quite yet. Now, we're not talking about a long delay. This will happen within probably under 15 seconds. Okay, but 15 seconds is a long time in system startup. Okay.
All right, thank you.
Yep. Okay, OSA Priority Queuing was an enhancement added to OSA. And what kind of happens is that there's a set of outbound data queues, and it was possible, based on how busy a guest is, for a guest to monopolize a lot of the bandwidth of the OSA. So what happened is OSA created something called priority queuing, and what we're able to do is create a set of 4 queues. Before it was 1 queue. Now we got 4. And OSA will service those in a fair share algorithm that avoids queue starvation. Everybody gets a shot at it. All these 4 queues will be serviced, but the system queue will be serviced more often than the low priority guest. Okay, so there are 4 levels, and they are serviced most frequently by system, then by high priority guests, and what we think of as normal and low. And it's the virtual NIC. Each virtual NIC can be assigned to one of those queues. It is enabled by default. You'd have to disable it if you didn't want it, but if you don't want it, just don't use it. It has an implication for the number of OSA subchannels that are available. If it's on, you have fewer of them, but you don't see people reaching the subchannel limit on OSAs either. So it's enabled by default in the OSAs, but you still have to turn it on your vSwitches. And it's the keyword Pri queuing on. Okay. Now you can't do it while the vSwitch is running. You basically have to do a set vSwitch disconnect, priority queuing on, set vSwitch connect. Okay, because he actually has to change how he's working with the OSA, so you have to disconnect and reconnect. The IVL VSwitch will automatically detect priority queuing availability, and it will use it for itself. And so if it's sharing OSAs with anybody, then it'll be using the highest level. Now, by default, you get this normal priority. By the way, it does only apply to outbound transmissions of OSA services inbound as they come. Okay, first come, first serve. But this is really to control outbound transmissions. And to specify it, you put this priority queuing uplink transmission, low, normal, and high. And yeah, that's, I can't pronounce it. Pick up link sticks. The idea here is that we may in the future end up wanting other forms of priority queuing, and we wanted to be sure that this is priority queuing on the uplink and it's for transmission. If there were eventually to become a way to handle receives, it would be, we wanted to leave some room there in the namespace. You can do this with set vSwitch grant, but don't do that. Just put everything you need in the NICDEF. Now let's talk about the HiperSocket virtual switch bridge. Now the bridge is nice because it allows me to exploit HiperSockets, but be able to exploit them in a way that says I can move a user who's using HiperSockets from one LPAR to another on a different CAC and still have it work, okay? In fact, so this is very similar to the ZOS HiperSocket converged interface, and this is what they use as a bridge. They don't use the same functionality that CVM does, but they're able to do the same thing. And what we have is there can be one bridge in an LPAR. I think we'll see that you can have up to 5 bridges per machine. But what we do is the guests are using HiperSockets, and their HiperSocket traffic travels, through the HiperSocket chipid on the machine to talk to the other HiperSocket users, unless it's trying to talk to a HiperSocket NIC, which it can't find here, okay? And if the destination of that is not found on this machine, then the HiperSocket firmware, not CP, the HiperSocket firmware will forward that to the bridge, okay? And the bridge will take care of getting that out onto the physical Ethernet, okay? So it goes out to the physical network. Now, it so happens to be that got located over an LPAR 4 or 5. And that OSA over there on that other CAC is the one that has registered those MAC addresses. So normally we think about vSwitches as registering the MAC addresses of the virtual NICs, the ones I create with NICDEF. It's also registering the MAC addresses of HiperSocket adapters, okay? So those now become visible on the network. By the way, it also means I can communicate with those even if I'm not using the HiperSocket bridge. Those external hosts I see out there in the Ethernet, they can talk directly to the guest's HiperSocket connection. Okay, so that's why we call it's a HiperSocket bridge. Okay, so the HiperSockets are now directly accessible from there. It means that if I ran this configuration, the guest doesn't even have to connect to a vSwitch in the usual manner. Okay, all it has to do is use a bridged HiperSocket, and then that would look like a local, a network connected, Ethernet connected network. Okay, it means that you no longer have the attribute that, by the way, guests using the HiperSocket, their traffic is secure. In this configuration, it may not be, because that traffic may travel out. Okay. Now, one of the things that's cool here is that the bridge itself supports path MTU discovery. So you think about when we're using a HiperSocket, the guests are using large MTU sizes, like, on the order of a 64K frame size, so a 56K packet size. Very large frames are going from guest to guest, right? And we like that. Well, those frames are way too large to put out on your Ethernet, which might be at 9228, might be jumbo frames, but it's not that big. So path MTU discovery, when you define that HiperSocket bridge, we'll see you specify the MTU size just as you would for vSwitch. And he will automatically detect those large packets and send MTU discovery packets back to the offending guest, who will reduce the size of the packet, resend it, and then the OSA is able to, and then we're able to send it out through the OSA. Okay, so the use case here, the one that I like to think about, is I have an SSI cluster, and one or two of the members are over on the other LPAR. Okay, and in that case, the LPAR, well, let's say he starts out in the same LPAR I am, or he's in an LPAR that's in the same machine I am. In that case, hey, I'm busy talking to him, no problem, through HiperSocket, but I relocate him over from LP3 to LP4. Well, traditionally, there's this big ripping sound as the HiperSocket comes undone, and now he's no longer, I can't communicate over the HiperSocket. Well, that was a pain. So my guests always had to have, I had to have dynamic routing, I had to have VEPAs, I had to take care of this so that my guest could have two routes. He could have a route through the HiperSocket, or if that's not available, go out through the OSAs. Okay. And with this, I don't need that. I still go back to, I have one interface, it's HiperSockets, and most of the time I'm doing this. Sometimes I relocate over to LP4 because I'm getting ready to do some service, but I'll move him back when I'm done. Okay. So the HiperSocket vSwitch bridge allows that to work, allows you to still go ahead and use HiperSockets. It used to be HiperSockets, yeah, you didn't really, in these kind of environments, you go, well, I moved the guest around, which made just implementing HiperSockets too much of a pain. Now, if you want to do it, you can. Okay, so when you're defining the vSwitch, you have to add a bridge port definition to it. Again, this only works for Ethernet mode vSwitches. You specify a bridge port, and you're going to point to a HiperSocket device. And that's the HiperSocket device that is used by the HiperSocket firmware to communicate with the bridge, okay, with the vSwitch. Okay, now for this to work, you have to go into the IODEF, and where normally you might see Charlie 0, you have to change that to Charlie 4. Okay, that enables the bridge. If you're using ZVM style dynamic IO, there's an external bridged keyword on the chip definition, but you do have to do that. That is not enabled by default. Okay, so if you want that, you have to turn it on, and then you'll be able to use the bridge port. All right, moving on to VEPA, or the Virtual Ethernet Port Aggregator, Virtual Edge Port Aggregator. Names kind of change around, but there's a standard that we use when we're communicating. We talked about it in our last session, the 802.1q standard. Okay, in 802.1q, I had said that when a frame goes out the OSA and enters the switch, 802.1q prevents, by rule, it prevents that frame from coming back in. The switch will filter it out. Imagine if you did a broadcast and that made it out to the network. You don't want it coming back into the same port, right? It would just sit there and bounce back and forth. Okay, that's also called packet reflection. And reflection is generally not allowed. Now, with virtualization, think about VMware, think about ZVM and the vSwitch, it became evident to the industry that they're going to have to do something about that, because there's a lot of traffic management that happens in the physical switches. In particular, we've got filtering. So there might be some intrusion prevention going on. One in particular is called ACLs, Access Control Lists. So they're called MAC ACLs. And you can actually control in a switch. You've seen it, you might have seen it in your home routers, in your home switches. There's oftentimes a capability to set up MAC filters, and sometimes for gaming purposes. But you can actually control what MAC addresses can get to what other MAC addresses. Well, that doesn't work. CVM itself doesn't have that capability in it, but the switches do. For that to work, I got to get the traffic out to the switch, and I have to allow it to come back in. Okay? So I might have that. I might have just monitoring going on. I want to see the traffic. If I have things that are watching for FTP traffic, for example, and checking for unusual patterns, it doesn't help me if the switch and that software cannot see the traffic. And remember, we short circuit the traffic as close as possible to the guests. So a standard was created, another follow-on standard. This has now actually become a full-fledged standard now. That when implemented, it relaxes that reflection restriction. Okay, the physical switch will then receive all guest-to-guest traffic on that vSwitch. Okay, and if it needs to come back in, it comes back in. Okay, it's a sort of a promise that yes, I know this reflection is going on. Yes, I'm aware. Yes, I'm not going to allow the packets to just ping pong back. I'm not going to get a broadcast storm when I do this. Got extra code to make sure that doesn't happen. Okay, so then I'm safe activating this. And this is and here again is the very complicated way you do that, set vSwitch, VEPA on or off. Now, what's kind of cool about this is that this happens, this detection of the existence of VEPA is something that is detected by the OSAs as it starts to communicate, when it first communicates at a very low level with the neighboring port, right? They're doing port negotiation. They're figuring out what speed they're going to run. Are we half duplex, full duplex? All that kind of stuff is being figured out. And one of the things that gets figured out at that same time is whether or not the switch supports VEPA. The OSAs don't. So they'll say, nope, I don't have that. You can't do that to me. But the physical switch will report that it does have it. So you do a query vSwitch and you say, oh, it says, VEPA is there. I can use it. So then you can say set vSwitch VEPA on. And first of all, it will verify that the capability is still there, that it hasn't been turned off. And there's no setup to make it work, okay, other than the set command. And you can do it dynamically. You don't have to turn the vSwitch off to do it. You don't have to disconnect it. So it does imply, so remember we had the isolate function I talked about where all the traffic goes out to the switch, but it's not the VEPA support. Yeah, forget isolate, use VEPA. Okay. And you want to use isolate when I have no intention that the guests are going to communicate with each other. I don't want the guests talking to each other. There I might use isolate. But in general, if I'm going to do something like this where it's about traffic monitoring and not about restricting, then I would definitely want to use VEPA for that. So this is very common. This is actually the standard, even though we've had our vSwitch for a while, VMware actually triggered in their virtual switch in vSphere, which is the management software, that they had to solve the same problem. And the standards community, the IEEE community got together and solved that, and we get to benefit from that. Now, switches are monitored, typically monitored in a network. And there is a management information base, or MIB, for the simple network management protocol, which it doesn't really manage networks, and it's not really all that simple. But SNMP is there, and there is a MIB that allows you to monitor a virtual switch the same way you would monitor a real one. Okay, so whether it's Nagios, whether it's Netcool, there are a variety of open source and commercial solutions that are used for monitoring switches. Now, there's a switch dashboard, if you will, that the network people have so they can see outages. They can tell if a port dies. They can have it light up on their boards. They can tell, some switch has a port failure. We need to go replace that. The bad thing about high availability is that it's good at hiding failure from you. It used to be, hey, it failed. Everybody starts screaming. I get told about it. You have to be a little bit more proactive and watch for failures. Now, ZVM, of course, outputs any failures in the OSAs. It'll put those out in the operator's console so your system automation can pick that up. But if you wanted to or needed to, or just wanted to play around and see this work, we do have an SNMP subagent capability for the VSwitch. So it is there. Frankly, not a lot of people use that. It might be useful if you want to collect metrics remotely from the vSwitch in terms of somebody saying, I want to actually see how much traffic because, I'd say, well, if you want to count traffic, get that information from the physical switch. You just want to know how many bytes are flowing over these interfaces. The physical switch will tell you because I have nobody else to talk to because my virtual switch can't talk to multiple physical switches at the same time. Okay. Short of using the link aggregation. But in that case, monitoring and data gathering already takes that into account. So I can really get all the information I usually would typically need from this. I can get it from the physical switch. Now let's talk about diagnostics. So the next couple of pages will be valuable, probably more valuable than a lot of the other stuff we've talked about, frankly. So first of all, you're going to need some commands. Query VM LAN, so that you can find out what some stuff at the system level. You can even find out what service has been applied. We put a little breadcrumb there that goes with some information on the website that you can use to figure out, well, what service do I have on my vSwitch? Query vSwitch active, or you can just do a query vSwitch details if you wanted to. I most often do a query vSwitch details. Find out what users are coupled to the vSwitch. You can find out what IP addresses are in use on those virtual NICs because CP watches for that stuff. I can see the MAC addresses. I can see data, how many transmissions, how many receives, how many discards. I can see that in terms of number of packets. I can see that in terms of number of bytes. Okay, so I can get a feel for traffic rates as well as the operation of the network itself. Query NIC. So query NIC details can tell me a lot about, because I can do that for my own NICs. Class G user can do that for himself. He can't really ask anything about the vSwitch, but he can certainly ask about his own NIC. Finding out if the adapter is actually coupled to the vSwitch. If there's been a couple failure, you'll see it there in the query NIC details. Now this chart is how we use discard counters. The one thing we don't really have problems with these days, you don't have bit errors. So things like, oh, something corrupted the frame, something that I had, I had transmission errors over the modem. Yeah, we don't have those. Usually you have a software error or you have a configuration error. You can discard something because of a malformed frame. Well, how in the heck did that get malformed? It wasn't sunspots, very unlikely. So I look at these discard counters. In the discard counters, we have transmission and receive counters, and then we have them on the uplink and we have them on the guests. And how I look at them is different, right? So I'm showing here, when you want to query the uplink counters, you do a query vSwitch active. When you want to query the guest counters, you need to do a query NIC command, okay? Now, if I'm looking at the receive counters, I'll look at the receive discards. If I see it's greater than 0, what I have is a definition problem, okay? Now, if you see small numbers of those, I just ignore it. If everything is working, I tend to ignore that. There's probably something out in the network which is creating a problem, but I don't really have to worry about it. But if I see the receive counter discarded, then it means that CP did not like the frame that arrived or the packet that arrived. Didn't like something about it. Now, usually what happens is it's related to VLANs. And so what happens is you've got, the most often case is actually the second bullet. You've created a vSwitch, you defined it VLAN unaware, and you plugged it into a trunk port, okay? And when you did that, VLAN tags started showing up. Well, a VLAN unaware vSwitch is VLAN unaware. It doesn't know what tags are. So it looks at the tag, thinks it's a protocol definition, says, I don't begin to know what that means, and discards it. Or you do have a VLAN aware vSwitch, but you're not running GVRP. GVRP is on by default, but that's the group VLAN registration protocol. And it's how vSwitch tells the physical switch, here's what VLANs I'm actually actively using. Don't send me traffic for something I don't have. Even though I have guests that are authorized for VLAN 55, if the guest isn't logged on and using it, then why should the switch send me any broadcasts for VLAN 55? I've got nobody to deliver it to. So why don't I just upfront tell it not to do that? So GVRP does that. But if you receive one and CP looks around and says, I have no guest associated with that VLAN ID, he'll discard it. If he gets a packet and he says, oh, that's for a MAC address, he looks around and says, I don't have it. He'll discard it. Okay, so sometimes it's just timing. So what you're really looking for are these things, you know, every time I do a ping, I see these counters increase every time, and it's not working. Well, then we probably have a trunk problem switch. Now, if I see that counter on the virtual NIC, now why would a virtual NIC discard something? It discards something when the packets arrive faster than the guest can consume them. So you got to watch out. If you have guests, you say, well, I have this database and I have this guest who's calling over to the database, and that database is streaming huge amounts of traffic back to me. And of course, it has a higher priority on the system. It's got a bigger share than I do. Why? Because it handles requests from multiple hosts. So it needs more capability, more bandwidth. So I do that. Well, that means its response in theory, if my machine was running really tight on CPU, it could, in theory, and I've seen it happen, overrun. It basically can deliver data to my virtual machine faster than I can consume it. Because you can't consume network data if you don't have access to the CPU, you can't consume network data, and it piles up. Okay, and when the queues are full, when the virtual NIC queues are full, CP starts, he'll hang on to it briefly, but then he'll start discarding that stuff. Okay, so I might be able to tell something about the relative performance if I see the receive discard counter greater than 0 on a virtual NIC. That's usually not a good thing because the guest itself doesn't control it. CP who's doing it. Now let's look at the transmission side of things. So transmission is the outbound stuff. And on the vSwitch, on the uplink, what does it mean? It means that CP has overrun the physical OSA. Now, why can that happen? Well, the OSA can be stuck, stalled, we call it. If that happens, you'll actually see messages on the operator's console, and CP will try to switch over to a different OSA. That's old school, right? Before we had link aggregation, you would actually fail that OSA automatically. You'd see stall detected, okay? And he'd try to recover from that. But he can only buffer so much data. When he starts getting, the guests are still generating data, and I can only buffer it so long while I try to get this link running again. And that's one thing we like about link aggregation. Something like this happens and OSA stalls, it's fine. I got other OSAs working. Deal with it in a moment. Okay. So in this case, you might got this nice processor and you've got a big thing and you're trying to use the slowest links you've got. Okay, so maybe you need to go from 1 gig to 10 gig. Okay, or you need to go to link aggregation. Okay, but it means that the queues, the OSA queues were full when CP tried to place another packet on the queue. So either OSA itself is jammed up and isn't working, or literally he's going as fast as he can, but we're still overrunning it. Okay, so that's a case of you go to the HMC, get down into the card information, and start looking at, what are the OSA data rates? What is it showing? Oh, crap! I'm at line speed now. It can't go any faster, and I'm overrunning it. So I need another one. Now, if I see this on a guest NIC, what does that mean? Well, it means that you have a virtual trunk port, not a physical one. You have a virtual trunk port, and then something tried to send a packet tagged for a VLAN that the guest is not authorized for. Okay? You're trying to deliver untagged frames to a virtual trunk that is not allowed to have them. The guest is configured as VLAN aware, but you plugged him into a virtual access port. Okay? So he's trying to use VLAN tags, but again, we have an access port, so those are no good, so they get discarded. And so there was that overrun, you remember, so up above, where packets are arriving faster. So not only will the receiving guest see his received discard count go up, the sending guest sees his transmission discard. So I'll increment both. If it's guest to guest, both of those counters get incremented. Right now, if I need to say, oh, look, I can't, the numbers are way too large, I can't be, fine. You can do a set vSwitch counters clear, and that will reset the counters for query vSwitch active. The guest counters are not reset unless you detach and reattach the NIC. If I keep this with me, of course, I have these presentations with me, so I keep this with me at all times. And when I'm doing a health check, I have the client send me the output of query vSwitch details. If they're having a problem with a guest, send me query Nick user, okay? And then I'll look at those. But I want to see, I'm looking for any discard counters that are non-zero. They get my attention, and then I start asking questions, and I may just decide that, oh, that's not a real problem. That's just a transient issue. I can't boil the ocean. I've got other fish to fry. I can't be tracking down every weird thing in the network. But if I see the accounts going up consistently, or there's large numbers of them, and by large numbers, it gets my attention if I saw in a minute, I saw the count go up by more than one. If I see that immediately after IPL, I've got an awful lot of them, okay, now that's weird. Why would that happen? Well, IPL is one of the hardest loads on the system as the guests are coming up. So I might see some performance problem right there. So keep that with you. In fact, keep it, shrink it down, have it laminated, keep it in your shirt pocket. People will think it's a pocket protector, but that's okay.
Alan, the vSwitch counters clear. Does that just clear the discards, or does it clear all the counters?
Clears all the counters.
Okay, thank you.
All right, so I showed this at the end of our last meeting, so that's a hint that we're coming to the end. The vSwitch is worth the time to understand because it is a major part of EVM today. It is the thing that between that and security, okay, networking, security, and network security probably occupy 85% of my time. It's the thing that people have the most problems with. It's things people have the most questions about. So it's worth, if you go, well, if you got to learn two things, learn security and learn networking. Third is probably storage. But there is a crossover between these things because I set these things up and there are security implications for them. So I do need to understand what I'm doing before I do it so that I can make the right choices. And CVM continues to invest in OSA technology and vSwitch technology. So we have a lot of things that we want to do. We have a lot of things we'd like to do. I mean, one of the fairly recent things was, and you can get this from the new function homepage. You'll also see additional enhancements that really don't come out on a release boundary, but come out as part of new function APARs. And one of the things we've been working on is detecting IPv6 IP addresses. Looking at those kinds of things, CP monitors traffic from an IPv4 perspective. So in an IP mode vSwitch, the guest registers its IP addresses. It's really easy for CP to know what IP addresses he owns because he tells them. Well, when you're in an Ethernet mode vSwitch, that doesn't happen. So the same way a real switch monitors ARPs, it monitors ARPs, and mostly what it really monitors are ARP responses. That tells a switch two things. One, what IP address or IP addresses can be found at the other end of that port, okay? If I followed that cable, where would I end up? So he can find not only the MAC addresses, he can then associate those with IP addresses. And that allows the switch to be smart. And CP is smart as well. So, we don't deliver to guests traffic that they don't need or can't use, okay? You don't need to tell me it's something where I can already tell you in advance, he's going to discard it if you give it to him. Well, the vSwitch can discard that in advance. Not discard it, it just doesn't even queue it up for delivery. That doesn't count as a discard. So we improve that in the IPv6 world. And so, people say, well, IPv6 is finally sort of coming into being, a decade after everybody said must have it now. Finally, it's starting to get some use. And people said, I noticed that you don't do for IPv6 what you do for IPv4. So, new enhancements come that way as well. We had, people wanted to do that. I'm not using link aggregation. I'm not using a port group. But I wanted to be able to fail over. I want to be able to demonstrate. I want to verify that my backup OSAs are working. There's nothing like having these backups, which you never know they're working until you have a failure. And then you cross your fingers, you pray, you find any sort of ancient ritual that you can use, and you just hope it's going to work. Well, the set vSwitch switchover command was added that let us say, well, this isn't about real, nice core enhancements to vSwitch protocols and what have you. It's like, no, it was an operational thing. I want to be able to manually tell the vSwitch, hey, switch over to another OSA. Go to my backup OSA. I want to verify that it's working. Oh, there, it worked. Yay. Oh, it's not working. I should get that fixed. And I'll switch back to the other one. and then I better go get that fixed. Okay, so I can be proactive with some things. All right, I'll turn that back over to Bill.
All right. Thank you very much, Alan. Thanks, everybody. Have a great week, and we'll talk to you next Monday.
Thanks for watching. If you enjoyed this video, don't forget to like and subscribe to see more videos like this one. Have a suggestion for another video topic? Feel free to leave a comment below.